Hey everybody, and welcome back to another video in this series. So it is finally time now to finally get in the anim graph. So I hope you're excited like I'm excited for this, although I'm partially excited but also partially anxious because this is one field that I've never been good at. So, you know, kind of like what I've mentioned in previous videos, that I'm still pretty much like noobish when it comes to Unreal Engine and whatnot. So I've only dabbled so far into the animation graph of just like basic animation stuff, like on third-person templates and stuff like that. But just for you guys to go in depth with how the game animation sample project Anim Blueprint is going, I've been doing a lot of research and stuff like that for this, just that way I can get more familiar with it and also help you guys figure out what's going on, just like how I tested and figured out what was going on, you know, from GASP to my other, you know, from scratch template in order to transition it into here, so that way I know how to best explain it to you guys, stuff like that, as best I can. So hope you're ready to get started. I know I am. So we are now going to start the first part of our anim graph by taking a look at the offset root bone that we had made in the first video when we went over the update essentials values. So, you know, when we take a look at the essential values, let me find it real quick. Up here is where we started making our, you know, default character transforms, or at least retrieving what our actor transform is. And then off of our offset root bone that we had gotten from the animation warping, we had, you know, turned it into a thing where we either get the default character transform to set as a root transform, or if it's enabled, then we, you know, grab that actual offset root anim node reference and then get the transforms and stuff off that, get the rotations, locations, other stuff, and then actually transferring them into the set root transform. So, however, in this case, basically because we only had basic stuff set on the offset root bone, the node in the anim graph, that for the moment within here, we're only getting the base actor transform. So now we can finally actually go over this and see what it actually is working. So I do have a lot of notes to go over with this one because I did, you know, jot a lot of stuff down to try to explain this, because there is a lot that actually goes into this offset root bone. And with my notes and how I've learned how to, you know, handle it and stuff like that, I feel like with my templates from now on, you know, when I create third-person games or stuff like that from scratch, I actually will be probably using this offset root bone because it can be very useful for animations from what I've researched, read, jotted down, gotten assistance with, stuff like that. So let's go ahead and explain what is going on in the offset root bone. So with my introductory with the root bone, is that it is a node in Unreal Engine 5's game animation sample project, or just off of the animation warping, that is used to adjust the movement and rotation of the root bone of a character's skeletal mesh during animation updates. This node can be handy for refining the way the character's root bone behaves to match the overall movement and collisions. So basically, let's go through each of these and I'll try to explain it in simple terms, so that way we can understand, you know, kind of what that introductory was for. So let's go with the functions up here. So this is where we'll be we're not going to be doing anything with these ones because even in the game animation sample project, these are set to none. But to just briefly go over what they do is that on the initial update, this function is called for the first time the node is updated, and it's where you would set up and initialize for the root bone adjustment to happen when the animation system starts. So basically it's similar to the, where is it at? In the event graph, kind of like similar to this of an initialize animations. It basically just runs once and is done as far as, you know, whatever function that you put in there, right? To be able to, you know, effectively start up animations. Then on become relevant, this function triggers when this node becomes relevant to the current animation. It activates when the animation system decides this node's results need to be used, such as when switching animations. So you could create, you know, pure functions or whatnot to be called in here to where you can set specific states or whatnot to where when that state becomes relevant, then you can trigger that function to then play the appropriate skeletal mesh transform adjustment, whether it's your translation, rotation, whatever, as far as that. So then, so if you were, say you had a specific thing for like wants to aim or wants to sprint, and you're putting that into a pure function to where it's like, hey, off of these different triggers, then we're gonna then make the offset root bone relevant or be called on when that, like, those specific states for those specific reasons, you want to offset the root bone. So with the last one on update, this is called every time the animation updates, meaning it happens continuously as the animation plays, allowing constant updates to the root bone's transform and rotation. So basically, that is kind of similar to the event graphs update animation, where essentially, like, regardless if we had a function placed in here to update constantly based off certain states, there is a lot of overhead that would be, put onto that, or at least more resources being used to be able to consistently and constantly update that. Because so the anim node, it acts a bit differently. It's kind of like on its own on update system, but there's a little bit more nuance to the anim graph as far as I'm aware of how it treats its animations. I don't know the full details on it, but it kind of runs on like its own on update anyway, so we're not gonna even put in like a thing in here anyway. As you can see that it's kind of like, calling, the different stuff within the anim graph anyway. So it's kind of weird. I got to do more research onto how exactly the animations within the anim graph are constantly on an update basis anyway, but that is the basic gist of those functions. So now with evaluation mode, this one is interesting just because you have two options. You have manual and you have graph. So let me pull over the game animation sample project for you, because I want you to see something, because I think this might have something to do with it that I found pretty interesting, right? So you'll notice you'll have the white, pulsating, line that shows you like the track, kind of how everything is playing, or at least the order of what things are playing in. But then you'll notice it's like purple, yellow, and green lines, right? It kind of threw me off for a minute, because I was like, oh, what could this mean, right? But I found out if you switch to manual, you do get like translation deltas and rotation deltas, and I think it would be part of this track because these are like changes, over time, or at least through the track. So to kind of like, or maybe not, I could just be overthinking it, but it kind of makes sense with like, this rainbow effect going on. But to get to the point of what both of those do is that the graph, the offset of the root bone is calculated on every frame by the following animation's graph flow. So the graph flow is basically what you're seeing here. So starting from motion matching, you see the white pulsating with the rainbowish colors, and this is the graph flow. So like every time stuff plays or animations play throughout the game, it is constantly looping through this and playing through all the necessary, like, additives like the lean or the stand, or, some dead blendings or default slots, leg IK, pose history, whatever, right? So it's going through that and updating based on the stuff given to it prior to getting to this node. With manual, however, when you look at it and you get these, these values for like a vector and, a rotation, is that the offset can be manually controlled based on external inputs or specific logic outside of the anim graph. So you can bind this to specific functions that you would want, like, the delta or the change over time for location and rotation to be played out through either a specific like pure function that you want called here, or off of specific values. However, it requires a lot more advanced understanding of like what you want, and also with how the system works, because you're putting in very, detailed stuff within your deltas if you end up doing that, as to where the graph, it'll just manually get your changes over time based off of what is being passed through there. So it, in a sense, what if you don't know how to do the advanced or complex stuff just like me with that, you would want to keep the evaluation mode on graph, so that way stuff gets evaluated or automated, you know, as it cycles through into that. So it also makes sense kind of where the offset root bone is placed based off of that, you know, talk. So let me go ahead and move that back over. And then the next parts to go into. So now we're getting into the settings, and that's where we're going to start making changes, because as far as the offset root bone is concerned, we do need to make a few functions that we will definitely be going over and tying them into the translation mode, the rotation mode, and we also want to get, you know, translation half-life. So I do need to expose that as a pin because we will be making something in there. One thing I did forget before we go into the settings is that because we now have an isMovingPure function, we had the halves velocity add like a placeholder because that's technically our should move if you compare it to the default third person template. So we had this as a baseline to clamp to our location velocity or our change in velocity. So now that we actually have the isMovingPure function, we do want to set that in there accordingly. So that way it clamps it to our moving velocity. And I'll go over, I know I explained it poorly in the first episode, but I have a better understanding of what this does now, which we're going to be going over here in just a moment. So now we can change this over, and I'm going to compile and save real quick just so that way nothing bad happens. So in regards to the translation mode within these settings, so this will control how the root bone's position or at least movement in a 3D space is adjusted. So this can affect how much and in which direction the root bone can move. So it is based on our movement or velocity or how it moves, and it more or less, a lot of the stuff that I go over is going to be tied more to our capsule component in a sense than to our character model. And it's kind of weird to wrap your head around for the moment, but as we go through building the functions that we're going to be building in this video, it'll start to kind of make sense. So going into rotation mode is that this is similar to the translation mode, but it defines how the root bone rotates during animation updates. Then with the translation half-life, this controls how quickly the root bone's position stabilizes over time. So a shorter half-life makes it adjust quickly, while a longer half-life makes the movement smoother but slower. So basically what that means is, like, the bigger this number, the smoother yet slower it's going to be. However, the smaller the number, how quicker the adjustments are made or the movements are made, but it might look a bit janky. So you kind of want to find that like equal or good balance, and you'll see when we make the function for this, like how the values that we actually use in this, which was actually interesting to me. So then let's go back into it. The rotation half-life, we're not going to be touching it, but we have the same values as we do in the game animation sample project. However, I still wanted to go over this as I found notes on the stuff that we're not adjusting really or making functions for, just to go over them. So rotation half-life is similar to the translation half-life, but for the root bone's rotation. This affects how fast the root bone rotation catches up, quote unquote, to its intended position. So this one, like it said, is similar to the translation half-life, where, you know, depending on how short or how long the half-life is, depending on whether it's adjusted or, you know, rotated quickly to catch up to its intended rotated position, or how long it takes, but how smooth it is when it gets to that point. So then the next one is the max translation error. This one, the maximum allowed difference between the current root bone position and desired position. This limits how much translation error is acceptable before correction is applied. So with this, you do want a low number for it to have like an acceptable error, like margin error or whatnot, for it to like be able to correct the location change or your translation change. But however, you could see that value is lower than 0, disable the limit. Basically what that's saying is, like, when you set to -1, kind of like how I poorly explained it in the pure functions, or at least when you compare it to the I want to say it was the rotation function that we set in the character blueprint. We're setting it to -1. Basically kind of like automatically sets or like super insanely quickly adjusts like what it needs to. So this one is the opposite of the quickly adjust. By when you set it to -1, then this thing is just disabled entirely, because if you give it a value of 0, then what we're trying to say is that we accept like 0 error margin as far as like the translation, the max like allowed translation difference. So if you set it to 0, it's almost like the same as setting it to -1 anyway. You just might as well disable it. But, you know, you could want, you know, an allowed difference or a margin of error for the current root bone position. It's just up to you and like what you know how to do with that. Then rotation's the same thing. It's, you know, it ensures rotation corrections aren't too drastic for this one. So, you know, it shows how much it can deviate before it needs to like catch up or correct itself kind of thing. So it's similar to that. And then the clamp translation to velocity, as you can see right here, because that's what we have to is moving. So this limits the speed at which the root bone can move, making sure it doesn't exceed a certain velocity when moving. It's like capping how fast it can translate in the scene. So again, that's what we're trying to make sure of, is that our offset root bone or our character / capsule, you know, like how fast the root bone can move. You know, because what you can end up doing is seeing if it moves faster than its like capsule or its intended speed, then you might have some like jankiness to an animation, or at least the root bone when it comes to stuff like that. So that's why what we want to try to do is like cap it, so that way our root bone is smooth, our animations are smooth, you know, it translates nicely within a scene, you know, stuff like that. Then you have, didn't mean to click on that. Then you have clamp to rotation, which is similar to the translation. It's just, you're limiting how quickly the root bone can rotate. So if you know, made a function for this one or set a certain value to this one, you can pretty much like, you know, screw up the offset root bone to where, you know, you'll see like your maybe body is like contorted in a certain way before your root bone and everything like catches up. So that can also make some janky results too. And then what we have here that is grayed out, I'm not sure really how to undo that really. I'm not sure how to ungray those out. I feel like there's something else somewhere, or it could be the, you know what? I just never tried that. But that is for the rotation speed. The translation speed, since we're binding it to a function, I believe is not going to have that check mark. So I guess we're not going to be touching that anyway. But to simply go over the rotation and translation speeds is that they're multipliers that scale the translation speed or rotation speed. You know, so for example, a ratio of 2.0 makes the root move twice as fast as normal. So if you did the rotation at, you know, 2.0, you would, you know, twice as fast, like spin around and stuff like that. So that's what you would end up doing here. So then obviously we have a tag, and, you know, the tag are, you know, labels for specific nodes. It's used for identifying particular node's purpose or configuration, or you could be using it for debugging or organization within your graphs and stuff like that. But like how we used it in here, we used it in order to call it into our event graph to get, you know, updated root transforms within our character transform. So then lastly, we have collision testing. So we have collision testing, and then we have collision test shape radius, and it's like I just wrote these down. So like radius and then offset. So what the testing mode does is you have these three options: disabled, shrink max translation, and planar collision. So the disabled is that no collision checks are done on the root bone. The shrink max translation reduces the root bone's movement when it detects a collision, which prevents it from moving too far into other objects, so like clipping to a certain degree. And then we have planar collision. This checks for collisions in a flat plane, for example, like for a floor or a ground, or for a ground or a floor. and this ensures that the root bone doesn't push into that plane. So this could be something useful for where it's like if you're falling from great heights and you have maybe something set to where like you ragdoll or too much force is applied. Planar collision can help kind of, make sure that the body doesn't push too hard through the floor or something like that. So that would be useful. However, we're going to keep it similar to the game animation sample project where they have this stuff. I believe they have it disabled. Let me look at it real quick. Yeah, disabled. Yeah, we have same values as last time, I believe, because we have, yep. All right, and then we have the collision test shape radius. So what that does is it defines the size of the shape, usually a sphere capsule, used for collision test. A larger radius means bigger collisions are detected around the root bone. So it's similar to like how you would do like sphere tracings and stuff like that to detect like hit objects or whatever. You would want to define the radius of that so it goes outward from your character to be able to detect upcoming like collisions. Then lastly, we have our collision test shape offset. So what this does is this shifts the position of the collision testing shape from the root bone center, and it's useful for adjusting where collision detection occurs relative to the character's body. So as you can see, we do have a Z offset of 60, so it's up 60 from our character. So that's kind of where the game animation sample project has as well. I guess for it's like upward collisions and stuff like that. It probably wants to do like higher collision sets since we already have like a forward facing collision detection due to our, the generate trajectory collision handling. So other than that, that is pretty much the technical overview of the offset root bone. So now we get to actually get into the fun parts now that I've gotten the boring part out of the way. So what we are going to do first is now make our functions that we will be putting in here. So let's go ahead and work on the first one, which is the translation mode. So in the event graph, and let me double check something because I think they have it as, yep, wanted to make sure I get the proper category for this one. So we're going to hit new function and we're going to call this get underscore offset root translation and mode. Yep, mode. I had to think about it. I knew I didn't camel case it. All right, there we go. And then let's go ahead and put this in the category that's supposed to be in along with the others that we'll be making, which is called root offset. Just like that, so because this is all going into the root offset node. So what we're doing in here, so what I want to do first, let me do it like this because I have notes for each individual function that we'll be creating. And so I want to, with this episode, I want to put them together first and then go through what's happening. So in this, what we're going to do is we're going to get an is slot active, similar to what we did in the last video with our peer function, where we are grabbing the default slot, just like that, of our anim instance. And then off of that, we're getting a branch node, and we're going to hook the is slot active into our condition. Then what we're going to do is we're going to call off of our true a return node. And within this return node, and this is something interesting because I had forgot that I had done this on my previous project, so I had to go back and relook at this for a moment. But we're going to add an output, and we're going to call it return value, just like how we would want to on a lot of our return nodes, unless you have something very specific you want to call it, if you had like multiple values you're returning. But for this one, what we're trying to get is called, I believe it's E offset root bone mode. So we're going to type in E offset root bone node. We want, mode, my bad. We want this one right here under the enumeration. So these should, if you followed along with the, I believe it was the second episode, or at least the first major episode when we did the update essential function or values, when we did the animation warping adding. So With that, we ended up, I believe, getting these enumeration values for the offset root bone. So that's what we'll be utilizing throughout these functions, is that E offset root bone mode. So essentially, like, what each of them is doing. So you'll notice when you drop down, you have an accumulate, you have an interpolate, and you have a hold, and you have a release. You'll have noticed that when we first created the root offset node, that we had some issues where, you know, we talked about like accumulation and releasing, but we ended up setting them to release because we wanted our character to just be able to do its normal animations till we got specific stuff set up. So what these are doing is, with accumulating, is that in this mode the mesh component moves the offset, or moves the offset will counter the motion and the root will stay in place. So let me go to my notes real quick as far as what we're doing in here, because what we are going to be putting together for our return nodes is we're going to be using release and accumulate in a lot of things, but this one's also going to have interpolate. So basically, release the offset. So when a montage is playing, because that's what this is trying to ensure, is that we're checking to see if a montage is playing. If it's playing in the default slot, the function ensures that the root bone's rotational offset is released. This means any rotational difference between the root bone and the capsule will gradually blend out, and the root bone will snap back to match the capsule's rotation. Once the offset is released, the character behaves as if the offset root bone node wasn't in use, meaning the root bone will be locked to the capsule's rotation. So what that's saying is that basically with these four values, accumulate means that it is accumulating like where the character or the capsule should be moving to, and then upon release of your button or whatever, it throws that accumulated movement data into the character and moves them to the appropriate location. So basically it's accumulating and holding positional data until you release, and then it shoots where your character should have moved anyway. Interpolation, basically with this one, interpolating means it's not going to hold anything, but depending on what kind of animations you have and what kind of data values you have set, the interpolation from like point A to point B, it is going to use best guess with as you're moving to that point. So this allows for speedier animations, stuff like that. Because you'll notice that as we go through this, there's going to be some nodes that we have as accumulate, and which will cause us to slow down, and one in particular would be like rotating in place, because we're trying to accumulate the points and then turn around, and withholding that using accumulation, that's what provides the slow, smooth animation of, like when we go to turn around. Interpolate will just be like, yeah, I'm gonna use my best guess to turn around, and these are the animations I'm gonna use. So that's what interpolation is like trying to get the best movement data between A and B, and just like AI guess its way through that, like in a sense. Not really AI guessing its way in there, but think of it in that term. Holding pretty much just means like it holds that animation or that movement data and just does nothing with it until like release. But like, it's kind of weird. So let me show you what I mean by that in the game animation sample project, because there is one thing that, you know, is pretty interesting, right? So you'll see here I got release and accumulate, because this is what we're going to be working on in the rotation. If we look at accumulate, so let's go ahead and compile and save, because I wasn't messing around with stuff. That when we go to move around, you can see that we are smooth, we're slow with our animations and whatnot, because it is accumulating the movement data and then appropriately getting the animations in order to make that smooth rotation or whatnot when we're aiming or strafing or whatever. So if we were to interpolate, I'm going to say compile and save that. You'll notice how much quicker we are, because what it's trying to do now is like best guess as far as what you'll be doing. So while I am in the wants to aim, it's like, okay, we're going to play out these animations because this is like the best guess of what we're trying to do. So it's just speedier, but it kind of looks janky as you see. So the animations aren't as smooth, but it still does its best to try to catch up to speed by interpolating that in between value or best guessing that in between data values. Then when you do hold, and we compile and save, you could see how, you know, we're just 360 no scoping with our, while we're holding the wants to aim. Like it is trying, you know, so that's what it's doing, is it's just holding that like the animation data and just not doing anything with it. And then release, let's compile and save, and play. As you can see, it's not doing anything in with that because what it's trying to do is immediately let stuff happen. So this would be useful if you had like kind of what we have going on in the third person template, where we have basic animations happening. So as like testing and stuff occurs and you want to try to do like rotations and stuff like that, you can at least flip through and try to do some debugging and whatnot till you actually set your values you want. So release, what we want to do in this case, like how I explained it, is that we're checking for an animation montage, see if it's playing. And then if it's true, then we're going to release after the montage plays to kind of get back quickly to our original position. So that's where you would want to use release for, you know. But then off of our false, what we want to do with that, you know, is we want to get other data, right? So what we're going to do is to continue off of this is we're going to off false grab a switch on E movement mode, and we want to get this one specifically because we're calling on our movement mode for on ground and air from our function that we have set up, and we're going to grab it within our states, and we're going to get a get node, and this is going to be based on our changes that occur within our movement mode when our gate changes for our motion matching table database. So with that being said, when we're in air, what we want to do is we want to release any sort of like animations we have, stuff like that, so that way we can play, you know, appropriate executions of our in-air animations. And then on the ground, we want to grab a branch node, and we want to get our first pure function. It's off of here. We want to get is moving and throw it into the condition. I'm going to move this back slightly. And off here, we want to grab two return nodes. We want to do an interpolate, and then we want to do a release. So with this, what we're trying to do is if we're moving on the ground, so again, if we're trying to get our translation, so if we are doing a montage, right, then, you know, when the montage is playing, when it's, you know, finished, then we want to release it so that way we can get, you know, ensure proper root bone rotational offsets, or get like the difference and like snap back to the capsule's, you know, intended rotation. But then off that, if no, you know, animation montage is playing, then we want to best interpolate or best guess our animations for when we're moving. Other than that, if we're not moving, then we're just releasing those in like animations, and we're going back to like our idle animations. So hopefully I explained that well in a sense. So kind of to go over why this matters for this one. So let me see if I go through. Yeah, so just to kind of go back over my notes with all these before I go over through dev comments, is that release the transitional offset, making the root bone lock back to the character's capsule position, and then interpolating the offset, allowing the root bone to move independently but gradually return to the capsule center, or, you know, best guess return, you know, the proper animation, stuff like that. I have to throw best guess and stuff like that to interpolate because that's what it's doing. So like interpolation in math is if you have a point on the graph of like 0, 0, and then a point of 2, 2, and you have to connect those points, there could be, you know, points on your way up there that are like scattered or approximate as you're approaching the 2, 2. And that would be considered your best guess approach onto like what data is approximate for getting from point 0, 0 to point 2, 2. So that's why I keep throwing in best guess, is like, I know I have a more technical term that I said with, you know, my notes here, but as far as what interpolation actually does, it's like the approximation or, you know, best guess kind of thing on going from point A to point B. So again, with just how it works, if a montage is playing, the character is airborne or the character is idle on the ground not moving, we're going to release the offset. So in these situations, the root bone's transitional offset is released, meaning the root bone will no longer deviate from the capsule's location. When the offset is released, the root bone blends back to the capsule's location, and the character's position in the world is governed entirely by the capsule. The root bone behaves as if there's no offset applied. Then if the character is moving on the ground and no montage is playing, then we interpolate the offset. And so if the character is moving but not playing a montage and is on the ground, the root bone is allowed to interpolate. This means that the root bone can deviate slightly from the capsule location based on root motion, which is, you know, how the animations move the character. Interpolation will still try to bring the root bone back toward the center of the capsule over time. This is particularly useful when the animation and capsule movement don't perfectly match, such as during starts, pivots, or other complex movements, or the capsule might be slightly out of sync with the animation. So, why this matters: during locomotion, interpolating the root bone's translation allows for smoother transitions between animation and capsule movement, making the character's motion look more natural and preventing noticeable discrepancies. When a montage is playing or during idle airborne states, releasing the offset ensures the character stays perfectly aligned with the capsule, avoiding any unintended drifting or mismatch in position. So that is my long-winded explanation of how the get offset root translation mode works. So what I am going to do is I'm going to move, unfortunately, the dev comment up into here, just because a lot of my notes and research kind of stems on better wording this. So, you know, this function is used to determine the offset translation mode. If we're playing a montage in the default slot, if we're in the air, if we're on the ground but not moving, we do not want to maintain any transitional offset. The release enum essentially blends out any offset, after which it would be locked into the capsule's location, just as it would without a root offset node. The interpolate enum means the root is allowed to deviate slightly from the capsule location based on root motion, but will always interpolate back to the center. So, with that being said, we are done with the translation mode. So we can then, I believe we need to set it to a pure and thread safe function. So off of here, we are going to then make it pure, and we're going to make it thread safe, and then compile and save. Then we can hop back into the anim graph, and then what we can do is click on our offset root bone and update our translation to have, it should be in right here, get offset root translation mode, and throw that bad boy in there. And then let's go ahead and compile and save, and let's see how that looks briefly. So you'll notice that we have some weird wonkiness goes on, but that is mainly because we don't have like motion matching and other, you know, data points in there. So like I was saying earlier, that a lot of the stuff prior to it, because we're getting the graph data and flowing that into the offset root bone. So right now it's trying to interpolate animations and other data, but because we don't have that other data, you know, in place of it, then it's just going to do this slingshot effect for the moment. So in order to just kind of have that for the moment, you know, to work properly, just set the interpolate to release, and then when we actually play now, you'll see that we move according to our basic animations. However, when you start putting in like your motion matching nodes, your additives, and like other stuff, then you want to ensure that you switch that back when you have that completed. So let's go ahead, compile and save, and I'm going to close that out, and we are now going to work on the rotation mode. So with the rotation mode, we are going to now create, where is it at? The right here function, and we're going to call it get offset root rotation mode, just like that. This one is very simple. We're going to call an is slot active because we want to gather if any montages are playing off of our default slot. And then we're going to grab a branch node, because if true, what we want to do is we want to grab a return node. And I know I'm going pretty fast, I apologize, but this one is very basic, very simple, and it's similar to what we just did in our previous one with the translation. So we're also going to grab, oh cool, did it already, an E offset root bone mode, and we're going to set the true to release just like how we did in the translation. And then for the false one, what we want to do is do an accumulate. So let me go ahead and go through my notes real quick and tell you why this is important and why it matters. So the get offset root rotation mode function, this helps us set or design control of how the root bone's rotation behaves depending on whether certain animations like montages are playing. So what the release is doing is it releases the root bone's rotation offset, meaning it will blend back to match the capsule's rotation, just like how we talked about in the translation one. However, the accumulate, this for the offset allows the root bone to rotate independently from the capsule. So to go over how it works, so if a montage is playing, we're going to release the offset. So when a montage is playing in the default slot, the function ensures that the root bone's rotational offset is released. This means any rotational difference between the root bone and the capsule will gradually blend out, and the root bone will snap back, quote unquote, to match the capsule's rotation. Once the offset is released, the character behaves as if the offset root bone node wasn't in use, meaning the root bone will be locked to the capsule's rotation. So if no montage was playing, this will accumulate the offset. So if no montage is currently playing, the function allows the root bone's rotation to accumulate or build up, which means that the root bone can rotate separately from the capsule, making it seem like the character is turning independently of their physical position or the capsule. This is particularly useful for root motion animations where the character's rotation is controlled entirely by the animations, like turns or pivots. The root bone continues to counter-rotate against any changes to the capsule's rotation, allowing smooth motion matching and steering behaviors. So, why this matters? During normal locomotion, the accumulate mode allows for more complex and natural looking animations where the root bone can rotate independently of the capsule. This is especially important in scenarios like turns and pivots, where the character's body may be rotating, but their physical position capsule remains aligned. When a montage plays, the release mode makes sure that the character doesn't drift or misalign by snapping back to the root to match the capsule's rotation. This avoids unwanted movements caused by interplay between montages and root motion. So, in practice, this function allows the system to automatically switch between maintaining an independent rotation for fluid animations and locking the rotation to the capsule when necessary, such as when performing specific actions like those in montages. It ensures a seamless blend between these states so the character's rotation looks natural and consistent with the intended animation behavior. So that is another long-winded explanation of what this is, because with how simple it looks, the accumulation does a little bit more than the interpolate. So let me go ahead and copy over the dev notes for this one. So I know if I had these in their own comment bubbles, guys, it would be just a massive thing that y'all would have to jot down. I don't want to put y'all through that kind of hell, but at least with captions and stuff like that for YouTube videos, you can always rewatch it to try to get my explanation again, so that way you understand how it goes, or just slow down the video so that way you can get that big chungus of an explanation that I've done so far with the translation and rotation. So I do apologize that I don't have the comments, guys, but when looking at the comments when I did them originally, I was like, geez, this is gonna be long. But anyway, with that being said, now we have our rotation set. So to see how it looks in here, let's go ahead and add it or bind it to our rotation mode. So you'll see right here, get offset root trans, or where is it? Oh, we didn't make it thread safe. So it needs to be pure and it needs to be thread safe. Now we should be able to call it translation mode. Where is it at? Let me do this. Click away from it. Am I not seeing it right? Rotation. We got transition. Let me do this. Rotation. No. Why is that not appearing? Let me see, because we got root offset. It's thread safe and pure. Go back into here. Bear with me, guys. I'll be right back. Alright, guys, I'm back. I figured out the problem. It was a very small oversight on my part. I didn't realize I didn't do it because of how much I was talking. But you have to ensure that in order for a pure thread safe function to be called anywhere on bindings, whatever, you have to ensure that you put a return value for its output, or you cannot call it. So that's why I was confused on why I couldn't call it, and it's just because I overlooked that small little detail. So now that I did that, you can see that the offset root rotation mode is there, and we can now select it. So now when we compile and save and we go to play, you'll see that we are not rotating like we should, because this is supposed to actually play out in an animation or at least a montage of sorts, so you could see how it looks very wonky, you know, and not rotating whatsoever. So in this case, until we actually get animations going, what we can do for this one is do a release. So now what we should be able to do, as you can see, is rotate how we should. So that's why with the interpolate on the translation and the accumulate on the rotation, you have to get the motion matching data and other stuff and steerings set up and ready to go before the offset root bone will actually start doing stuff. So now that we got that, what we can do now is we can move on to our, what was it? We have, yeah, the offset root translation. So let me see here. I gotta check something. So I think we got, yeah, it's literally just this one left. So go ahead and create a new function, and we're gonna call it get offset root translation half-life. Just like that. I want to make sure I didn't misspell it. Yep, we got that. All right, cool. So now that we got the translation half-life, this one is also pretty simple. So in this one, we're going to grab our movement state, and then what we're going to do is we're going to switch on movement state. So whenever we have any of the appropriate, you know, animations, this is where we call in our half-life. So both of these are going to have a return node, and they are going to have outputs. However, they are not going to be this. They are just going to be normal float values. There's not any special parameter we need to call because we need to do our own floating half-life. So, you know, just make sure you do a return value on these or you won't be able to call it. So then let's go ahead and copy. Oop, what did I do? Let's go ahead and copy and paste that and then throw into moving. So we're going to give this return value just like in GASP 0.1, and then for the moving we're going to give it 0.2. Let's go ahead and compile and save, and now let's discuss what is going on here. So let me pull up my notes. So with the half-life, this function this function And the offset root bone controls how fast the root bone's translation or position catches up to the capsule's location and is based on the character's movement state, such as whether we're idle or moving. So, how it works, we have fast interpolation and we have smooth interpolation. And I'm using those terms because technically our idle return is a fast interpolation because of how low its value is. And our moving return node is a smooth interpolation because it's a bigger value, quote unquote. I know it's small because we're within the tenths of an integer, but for a half-life time, this actually is pretty long. So just to kind of go over the fast interpolation, so the first return node is if the character is not moving, the translation offset needs to quickly blend back to the capsule's center to ensure the character's root bone is perfectly aligned with the capsule when stationary. This means that the root bone's translation will snap, quote unquote, back to match the capsule quickly. So the character appears correctly positioned. The function sets a short half-life for interpolation in case, meaning the root bone's position catches up to the capsule quickly. However, when the character is moving, we smooth out the interpolation. So while the character is moving, the interpolation is allowed to happen more smoothly and gradually rather than instantly snapping back to the capsule. This smoother blending helps maintain fluidity in the character's movement, making it feel more natural, especially during complex transitions like starts, turns, and pivots. The function sets a longer half-life when moving, allowing the root bone's position to interpolate back to the capsule more gently over time so the character's movements feel fluid. So, what is the key concept of a half-life? So the term half-life in this context refers to the time it takes for the root bone's translation to move halfway toward the capsule center. A shorter half-life results in a quicker interpolation, while a longer half-life makes it slower and smoother. In practice, a fast interpolation when it stops moving, you want the root bone to align with the capsule as quickly as possible, ensuring that the character is perfectly positioned when idle. For the smooth interpolation, while they're in motion, the function allows for more gradual interpolation of the root bone's translation, creating more natural and smooth movement, especially in transitions. So, with that being said, this basically allows you to dynamically adjust the speed at which the root bone's position aligns with the capsule. So, with that being said, let's go ahead and copy the dev note into here. Since again, I don't have, what I'm explaining is too long. So again, guys, I really do apologize for that. I couldn't give you awesome notes for it. So let's go ahead and compile and save. Let's go back into the anim graph and let's bind this bad boy to the translation half-life. Actually, did I not make it I keep forgetting to do that. So we need a pure function and we need a thread safe. So this time, instead of return value, I forgot those important details. So now, yep, there we go. So there you go, ladies and gents. We now officially have the complete offset root bone as shown in the game animation sample project, and we went over it in great length. So I am really hoping that my explanations from my notes made a lot of sense. I know some things were repeated, but it's one of those things again where I'm trying to kind of beat it in to a point where hopefully it's understandable. So we are now done with this part. So we have our first major part of the, the anim graph for the game animation sample project. So let's go ahead and to celebrate, put in the dev note, because again, we are done with it. And we can actually finally talk about the dev note for more, because now we should have hopefully more clarity on it. So as you can see with what they said, that it is an experimental node. So, the root bone node dynamically applies an offset to the character's root bone in order to keep the mesh more planted when capsule movement and animation data do not match. For translation, the root bone is allowed to deviate from the capsule within a fixed radius during locomotion, which is most notable during starts and pivots. When stopping, the offset will release or blend out so that the character stays at the capsule center when idle. For rotation, the root bone is allowed to rotate independently from the capsule, so the rotation is entirely controlled with root motion, which gets steered within the motion matching node to always align towards the target. This makes it easier to perform more complex rotational animations like turn in places, turn starts, turn pivots. And then some known issues is that the translation offset has no collision checks, so it can clip into geometry or the blocks that we have in the level, or maybe like some assets. When a montage plays, we release the offset. However, the release in conjunction with motion warping in the montage might cause undesired movements. And this is how the offset is interpolated out as hard-coded at the moment. So let me see if I have my notes for what they said in here. Yeah, so to kind of go a little bit more brief or more simply into what they mean with their known issues. So the root bone's translation offset doesn't check for collisions, meaning it might move through walls or floors, which will be fixed in future updates. I think the update I saw is going to be coming in 5.5, so I'm looking forward to that. The montage interactions, like how they were saying, when playing montages, releasing the offset could sometimes cause strange movements due to how the root bone adjusts. And then with interpolation, the way the root bone blends back to the capsule is currently hard-coded and not customizable, but this is expected to improve in the future release. And again, I think I saw something about that 5.5. So again, I'm looking forward to that because we are getting a lot of good changes in that. So with that being said, guys, let's kind of take a brief look at some things within the game animation sample project that we can hopefully go into in the future, that we will get to in the future. It's just not going to be right away because I'm trying to set up the simple stuff in here as we get to the more hard stuff. So within motion matching, with how they were explaining it, so with us reading that comment bubble, the reason a lot of the animations, or at least our movements, are janky or don't do anything or just rubber band us somewhere is because we have yet to do this where we reset root transforms. We don't have steerings in place like these in order to account for our stuff. However, depending on when 5.5 is out now, I think in preview. So I am going to look at that when I'm done with this series and try to see what changes they've made and actually discuss those. But as you can see here, this will be removed in future releases. So I'm wondering if they've reworked heavily on this one to better, I guess, motion match animate our character for the like offset root bone node to work more effectively. So I'm curious to see how that looks. I don't want to download 5.5 right now because I'm trying to focus on the series, but once the series is done, guys, I will look at that to try to decode what is going on in there and discuss any sort of changes that are made, seeing what kind of motion matching databases we have, stuff like that. So if you did like this, please watch my other videos. You don't have to, but I would just say take a look at my other videos just that way you can kind of get a better grasp on it. Like I said in my previous video, I know the old ones can be very cringy, but if you haven't already watched them, I just recommend doing it so that way you know exactly what's going on bit for bit, as much as I could explain in my more newbie-ish mindset at the time. But other than that, you know, just keep a lookout for my future videos. And with that being said, ladies and gentlemen, y'all have a great rest of your day, and y'all take care.